Hey, welcome back to my channel. In this video we are going to learn how to name alcohols and phenols. We are going to convert names to their structures first, and after that we are going to convert structures to their names. As you can see, we are almost reaching at the heart of organic chemistry. So get ready to jump into the cold water. I will do my best to keep it as simple as possible. The rules to name alcohols are simple. Find the longest chain that contains the hydroxy group and replace the ending of E with ol, and E is deleted to prevent the occurrence of two adjacent volvae. The counting must start from alkane chain closest with the hydroxy group. After, number other substituents in relation with the position of hydroxy group. When you write the name, list the substituent in alphabetical order regarding to their position number on the structure. Let's see a general overview of alcohols and those examples that I mentioned above. So as I said, E is replaced with ol. We have primary alcohols, secondary alcohols because it contains two of these, one of these primary, and tertiary alcohols. Do we have quaternary alcohols? No, it is not possible because we have to keep somewhere the hydroxy group in order to name it as an alcohol, okay? The most common known are ethanol, that was invented or discovered around 9,000 years ago. The oldest one is the ethanol. That was done on that time with fermentation of grains. Okay, phenol is another commonly known name for alcohols. Those other names are common names that are accepted by UPAC nomenclature. So we have benzylic alcohol, allylic alcohol, ethylene glycol that is used in the car to prevent the freezing of the water, glycerin that is used in cosmetics, right? So let's move straight to the first example, 1,4-pentane-diol. So it's an alcohol that contains two hydroxy group. The parent name, as always, you have to identify it, is pentane. So in this case, it should contain 5 carbons. Position 1 hydroxy. And you can place numbers, it's advisable, and at position 4, another hydroxy, and fill them after with hydrogens. That's it, done for the first structure. Let's move to the point B. It looks more complex, but don't worry. Write first the structure, and after that write the orientation according to the Z designation. That means the most priority groups are on the same side. Butane is the parent name, 4 carbons. So 1 ol, so the hydroxy at the position 1, and it rules all other positions, 2, 3, 4. So you have 2 butane, so in is at the position 2, and 2 ethyl is at the position 2. So this should be the structure with filling also with hydrogens, sure. Now, let's write according to the Z designation. What you're going to have, a double bond, and the most priority groups are going to be on the same side. And that's it, done. This is the structure. Okay, let's move to the point C. Point C, cis-2-chlorocyclohexanol. So it's a cycle with 6 carbons, and it contains a hydroxy group I'm choosing by my own toward me, and if I choose it toward me, the hydroxy group, I should choose also for the chlorine toward me in order to make it cis. So chlorine is going to be here, and the 2 hydrogens are going to be behind the plane. That's it, done. Let's move to the point D, 2,6-dimethylphenol. So phenol is this one, as you may remember from my previous video about the aromatic compounds. And at position 1 it rules also, sure, the phenol. So 1, 2, 3, 4, 5, 6. You can count also on the other side, it's the same. So position 2, methyl. And position 6, another methyl. That's it, done. Now to convert the structure to their name. Give the UPAC names for the following structure. Okay, as always, parent name is obviously this one. 1, 2, 3, 4, 5, 6, 7 carbons. We are going to start counting on this side or in this side. We are going to start counting on that side that the hydroxy group is at the smallest position. So in this case, we are going to start on this side. So let's place numbers. So heptanol is heptane is the parent name, and it's going to take all because it's an alcohol. But you have two hydroxy groups. In case you have two hydroxy groups, it's going to have that diol. Okay, if you have three, triol. Okay, so what we are going to do, we have also a metal here that is at position 5. Okay, first we have to write the metal, 5 metal. After that, we have at position 2 and 4 heptane diol. Okay. As you can see here, I didn't remove the E, as I said previously. Those are the cases that you have this D or tree that they are not two adjacent volvae. You have to keep it. In all other cases that two volvae involve adjacent, you're going to remove it, okay? Let's move further fast. Okay, let's move to the second compound. Now here, those two bromine and hydroxy are in trans position. So it's going to be trans. This is going to have the first number 2. So 2 bromo. Right? Trans 2-bromocyclopentanol. Okay, something else that we can add here, the exercise does not require that, but if the exercise required to add RS designation, you can say that this carbon here is chiral, and this carbon here is chiral, and this carbon here is chiral. This carbon here is chiral and is S configuration. Why? First priority group, second and third. Because hydrogen is toward us, you're going to take the reverse. So instead of R, it's going to be S. This one here. And this one here, this carbon here, is going to be first, second, and third, is this side here. First, second, and third, and the hydrogen is behind, no need to make changes, so it's going to be S also, this one, if you want to assign the designation. Okay, let's move further. So phenol is going to be the parent name here. What do we have? Now the counting starts from 1, 2, 3, 4 to keep as low as possible the number of substituents in the ring. So it's going to be bromo is going to be first due to the alphabetical order that is not directly related with the numbers. It's sometimes maybe the same, but it's a coincidence, okay? Alphabetical order has to be respected. Bromo, so it's 4 bromo, 3 methyl, right? Okay, let's move further. Point D, what do we have here? We have a double bond and an hydroxy. So in this case, counting again is going to start from here, 1, 2. So what we are going to have? Now, the double bond is at position 2. 2 cyclo pentinol. 1 ol, to be precise. 2, it remains for the position of in, for the alkene, okay? Cyclo is a cyclopentane, 5 carbons, and 1 ol. The hydroxy group is higher in priority compared to the double bond, okay? To cyclopentanol. Let's move further. Let's move to this one. This looks like complicated, but it's much more, it's even simpler, it's even simpler than this one. Why? As I said, the rule is hydroxy has the highest priority. This has the highest priority. It doesn't matter if this has 6 carbon ring, and this here the parent chain is going to be 4. This rules hydroxy groups. So numbering is going to start on that side that the hydroxy has the lowest possible number. It's 1, 2, 3, 4. So in this case, you have methyl substituent and phenyl substituent. Okay. So how we are going to add the naming now? Methyl is priority in the alphabetical order compared to phenyl. So it's going to be 2 methyl, For phenyl, 2-butanol. Butanol. Right? Okay, the last structure I'm leaving to you. If you were able to give the name, write that in the comments down below of this video. Thank you so much for watching, and look forward to see you to the next video that is related with the preparation of alcohols. Peace.